We will now be looking at some particular examples of how to use trigonometric functions to solve problems. So trigonometric functions can really be used in a wide variety of situations to figure out things such as the length of something, the height of something, the angle of something. And here we have just some examples. We will be doing many examples throughout the entire course. And here's uh, some examples. So here's the first one. It says the builder of a parking garage wants to build a ramp at an angle of 14 degrees that covers a horizontal span of 80 feet. How long would the actual ramp be? And give your answer to 4 decimal places. All right, so drawing a picture is always going to be helpful. So you should always start by drawing a picture. So this one, okay, says that we're going to have a ramp. So let's draw something like that. That's the ramp and that's the horizontal. And they're telling us that the angle is 14 and the horizontal span, so the horizontal would be that. The horizontal span is 80 feet, okay? And now if you draw the perpendicular, we complete this triangle. Now we have this triangle and the question is how long is the actual ramp? So this is the actual ramp right here. We have to give it a name, like some variable, whatever variable you want. You can use x. I'm going to use c. Okay. And the question is, what is c? What is the length of c? Well, at this point, now that you have a right triangle, you can use trigonometry. And what you have to do is think which of the trigonometric functions, and you're going to focus on the basic three, the first three that we introduced, sine, tangent, or sine, cosine, or tangent. So the three functions from SOHCAHTOA. So which of those three functions relates these three numbers? Okay, so which of the three functions relates these three numbers? And if you don't know right away, you can just go systematically through all three of them. Think about all three of them. So for example, let's start with sine. Does sine work? Well, sine of 14 would be so, using SOHCAHTOA, so opposite, which is the height, over hypotenuse. We don't know the height, we don't know the hypotenuse, so that's two unknowns, that's a dead end. We don't want sine then. So going to the next one, that would be cosine. So so that means cosine is adjacent over hypotenuse. Yes, that's the one we want. So we want to use then cosine. So cosine of 14 degrees equals, so adjacent, which is 80, over hypotenuse. And now we have this equation, and we can find c from there. So we just multiply by c both sides or cross multiply. We're going to get c times cosine of 14 equals 80. And then dividing by cosine of 14 on both sides, we're going to get that c equals 80 divided by cosine of 14 degrees. And that's our answer. Now we have to put this in the calculator and round it to 4 decimal places. Okay. As soon as you go to your calculator to plug this in, make sure that you always make a habit of looking at this. Okay, you have to make sure that you're gonna use the calculator is set to accept the correct form of the angle you're dealing with. So we're dealing with degrees, so that should say degrees. All right, so that means the calculator is good to go. So now we enter 80 divided by cosine of 14, and that gives us that, which we're gonna round to 4 decimal places. So this is 82.4491, and this is feet. So that's the length of the ramp. And that's it. Okay, let's do another one. This one says the angle of elevation of a flying kite is 80 degrees, 36 minutes, 20 seconds. If the other end of the 96-foot long string attached to the kite is tied to the ground, what is the approximate height of the kite? Okay, so we have a kite that is tied, and the string is tied to the ground. Okay, so let's draw a quick picture. So we have a kite and the string is tied to the ground, and this is the angle of elevation is 80, so it's kind of close to 90, so maybe we can draw something like this, although the accuracy of the picture doesn't really matter. And then this angle right here is 80 degrees, 36 minutes, and 20 seconds. Okay? So that's more or less it. Now, I want to draw the perpendicular, so this picture perhaps is not the best, but we can draw something like this. Okay, it's the same one, I just didn't have enough space there. It's supposed to be the same one. Okay, so then, so that angle is that angle, and then the string, which is that, would be 96 feet. So 96 feet. And then we're trying to figure out, what are we trying to figure out? We're trying to figure out the height of the kite now. Now we want to figure out the height. Okay, now again, you have to think which of the three trigonometric functions relates the things that you know and what you're looking for. So I want a trig function that relates this angle to the hypotenuse and to this side. So which of the three trigonometric functions is it that relates the angle, this height, and the hypotenuse? If you said sine, then that's correct because this, the sine of this angle, according to SOHCAHTOA, so would be the opposite, which is what I'm looking for, divided by the hypotenuse. So yes, so this we're going to use the sine. So sine of the angle is this, 80 degrees, 36 minutes, and 20 seconds equals, so opposite over hypotenuse. And there you have it. Now, to find the h, we have to multiply both sides by 96. We're going to get that h equals 96 times sine of 80 degrees, 36 minutes, and 20 seconds. Okay, now we're going to put this in the calculator. My calculator allows me to enter that as is. I can enter degrees, minutes, and seconds in this calculator. In your calculator, you have to figure out how to do that, or you could always convert this to decimal notation. Convert it to DDS. Okay, and remember how you do that. So real quick, it would be 80 plus 36 divided by 60 plus 20 divided by 3600. You're going to get that, and you're going to get just a regular decimal degree. And then you can enter in the calculator. I'm not going to do that because I don't need to, because you see my calculator has right there this button that says degrees, minutes, and seconds. So I can enter that just as is. I don't have to change it to decimal. Okay, so that's what I'm gonna do. So I'm gonna enter 96 times, and again make sure it's on degrees. So it is. So times sine, and then 80, and I hit that to enter degrees. And now 36, and I hit that to say it is minutes, and then 20, and I hit that, and I go to seconds. Enter. Close, and that's what we get. We get 94.71. Uh, we actually want to round it to the nearest whole number. Those are the instructions this time. Round your solution to the nearest foot, to the nearest whole number. So, rounded, this is about 95 feet. So the kite is about 95 feet high in the air, high up in the air. All right, so now let's do another problem. This one is about the shadow of a tree. So it says, a tree has a 30-foot shadow cast by the sun. So the sun is shining down on the tree is casting a shadow, and the shadow is 30 feet long. If the angle from the tip of the shadow, so this is the shadow, right? So that's the very tip of the shadow. If the angle from the very tip of the shadow to the top of the tree, to the tippy top of the tree is 57 degrees, and that angle can be measured with an appropriate instrument. A theodolite is an instrument that will measure angles pretty accurately, and it's an instrument that surveyors utilize for measuring angles. So measuring that angle is not a problem. Okay, so suppose that angle has been measured to be 57. Question is, what is the height of the tree? And of course, we can measure that shadow really easily as well, because you just that's the shadow, that's the tip. You just measure all the way to the bottom of the tree. So those two things can be measured easily. So with those two things, can we figure out the height of the tree? And the answer is yes. Trig makes this very easy. Okay, so if you look at the picture, what we really have going on is a triangle, which I'm going to draw again here. So we have that to be 57, and this is 30, and 30 feet. And we're looking for the height of the tree. The question is, what is that height? Okay, now we stop and think about the trigonometric functions and think which trigonometric function relates all these three things: that angle, that 30, and that h. If you said is a tangent, then you're correct. That is the tangent. So tangent relates that which is the opposite side and the adjacent side. So katoa, you can see sine and cosine utilize the hypotenuse, which we don't even know what that is at this point. So let's use then the tangent. Tangent of 57 degrees, so katoa, is the opposite side of the angle over the adjacent. So h over 30. And now multiplying by 30, we're going to get h. H is 30 times the tangent of 57 degrees. It says round your answer to 4 decimal places. So let's do this. So this is going to be 30 times tangent of 57 degrees. And my calculator is in degrees, so it's going to interpret it correctly. And this is 46.1959 to 4 decimal places. That's what we get. And this is feet. So that is the height of the tree. The tree is a little over 46 feet tall. And we could even change that to inches and like find the height exactly in terms of feet and inches, but we don't need to do that, okay? But we could if we wanted to. And here's the very last example. So in many surveying problems, it is frequently necessary to determine the height of some distant object. So something far away, let's say a mountain, uh, or some other object that perhaps is not that big, but it is impossible, for which it is impossible or impractical to measure how far away the object is. In the case of the previous example, which is just a shadow, that's easy to measure. Uh, from here to here, 30 feet, that's not difficult. But if it's something that is, the distance is far bigger, that would be impractical or even impossible. So, how do you figure out the height of the object in that situation? Well, there's a little formula that involves trigonometry. And this formula is actually derived in the textbook. You could read that page and see how they come up with the formula. The formula, of course, does not fall from the sky. It comes from somewhere, and it comes from doing some geometry and trigonometry, and some trigonometry and algebra. And they just figure out that that's a formula. So if you want to read the explanation, you can read it in the textbook. I'm sure you could follow it if you just um, read it carefully. So here's the situation. You have some distant object, okay, and the object is here, and the object is tall. Let's say it is the height of the object is h. Okay, it could be a tower, a building, a mountain, be whatever. So it's far away and it's tall. So how does the surveyor figure out then the height? Well, this is what they do. They stand in one spot and they measure the angle with a theodolite, okay, from the angle to the very top, to the very tippy top of the object. So they measure that angle and they take note of it, alpha. And then they walk a distance further away, and then they measure again the angle. And they take note of it, beta. And of course, they could have started with this one and then walk forward and then measure again. The order does not matter, but you have two angles. And then you can take note of how much you walked from here to here. Okay, and that distance is d. So once you know this distance right here, d, and these two angles, you can use this formula to figure out the height of the object. And the height is given by d, which is the distance divided by the cotangent of beta, which is this angle right here, minus the cotangent of alpha. Beta is an angle that is smaller than alpha. Okay, alpha is the bigger angle of the two. Okay, and here's an example where we could use this formula. You don't have to memorize that formula. We're just going to use it. Okay, says approach from one direction. Mount Baldy rises out of a perfectly level desert plain. A surveyor standing in the desert some distance from the mountain measures an angle of elevation between the desert floor and the top of the mountain to be 60 degrees, 1 minute and 6 seconds. And then she bends back up, so uh, she walks in this direction 1,000 feet, and then measures the angle again with her theodolite, and determines the new angle of elevation to be 56 degrees, 3 minutes and 23 seconds. Question is, how high above the desert plain does Mount Baldy rise? In other words, what's the height of the mountain? All right, so this is actually Very straightforward because we have the formula. So we're gonna do it here. The height of the mountain is the distance d, so that's 1,000. All that over the cotangent of beta. Beta is that smaller angle, so the cotangent of 56 degrees, 3 minutes, and 23 seconds minus the cotangent of 60 degrees, 1 minute, and 6 seconds. Okay, we just put this in the calculator and we get it. Remember that if you don't know how to enter that in calculator because you don't have that button or for whatever reason, you can always convert that to decimal and then enter it that way. So convert to decimal, 56 plus 3 over 60 plus 23 over 3600. All right, I don't need to do that. I'm just saying that you could. So 1,000 divided by, and we have to put parentheses because we have two terms. So we have to put parentheses. And then we're going to enter. Cotangent. We don't have cotangent. But what is cotangent? Cotangent is just 1 over the tangent. Okay, so the cotangent is just 1 over the tangent. And then now let's enter the angle. 56 degrees, 3 minutes, 23 seconds, close parentheses, minus, now the cotangent. The cotangent is again 1 over the tangent. So 1 over the tangent of 60 degrees, 1 minute, and 6 seconds. Close parentheses. That closes the parentheses of the tangent, not the parentheses of the bottom. Okay, now I'm going to close the parentheses. One more parenthesis to close out the bottom, the denominator. And now I can hit enter. And look at that. That's our answer. Let's use 4 decimals as well. So this is going to be 1, 0, 4, 0, 0, 0.0026. And this is what? This is feet, because everything, the number on the top was given in terms of feet. So this is actually feet. And this is so small. So we can say this is basically about 10,400 feet. Okay? So just follow rounding instructions if given.